First, I apologize if you're hearing something in the background. Hudson's decided that it's time to chew on his bone. So we're just going to let him go so he doesn't bother us. Anyway, let's talk about what we just saw. The function has a relative maximum point. So a relative maximum point, or local maximum. So this word relative means a local maximum. That means it's not the absolute maximum. It is just, it might be an in-between. So we might have a little hill here, but then maybe we have another hill here. So local means that it's some of them. It just might not be the absolute one. Okay. But when we change from a sign that is increasing to decreasing, the reason that happens is because, just like I drew over here, we have a positively sloped line to a negatively sloped line. So think about all of those tangent lines that you could draw if we were talking about a maximum point, right? So if we were talking about a maximum point, we'd be looking at tangent lines. This is a positive tangent line, right? This is a positive tangent line. This is a positive tangent line. But then all of a sudden, after we pass this maximum point, then our tangent lines, the slopes, become negative, right? So that's why we go from a positive to a negative in the first derivative. Okay, keeping that in mind, when we have a relative minimum point or a local minimum, they mean the same thing. It's because we went from decreasing to increasing. So just like that last one, we went from decreasing to increasing, which caused a minimum point. So I'll show that again with the slopes. So here's a tangent line for a first derivative, right? That has a negatively sloped line. That is a negatively sloped line. And once we change to a positively sloped line, it's because we went through a minimum point. What's the slope of this minimum point? Oh, well, the slope of that minimum point is 0. So we went from a negative to a positive. Okay, so the relative minimum maximum points are called your relative extrema. Okay, so your extremes, basically. Your highest and your lowest. Maybe not the highest and the lowest over the complete graph, but in certain areas. So the first derivative test tells us that if the first derivative changes from a positive to a negative, then we have a maximum. If the first derivative changes from a negative to a positive, then we have a minimum. Now what we're going to look for is that point, okay? That point there. And that point is found by the x-coordinate is the 0 of the first derivative, and the y-coordinate is found by taking that x-coordinate and putting it back into the very original function. Remember, whenever we're looking for the y-coordinate, we go back to the very first original function. Or if we're talking about displacement, velocity, acceleration, we go to the displacement function. Okay, so let's go ahead and take those functions that we dealt with before, and let's apply the first derivative test. So use the first derivative test to find the relative extrema, or the extreme points of those functions. So the first thing I'm going to do is I'm going to go back and look at the work we did originally. Okay, that was the original work we had, right? So I'm just going to shorten that up a little bit here so we don't take up too much space. Okay, it's going to look a little awkward because I'm squishing it just this way. But, oops, those are the first derivatives that we found in addition to the sign diagrams. Okay, so we've already done that work. Now we're just going to interpret it basically. So here on the very first one, we have it changing from a positively sloped line to a negatively sloped line. Positive to negative. That means that this thing is going from a graph, and I'm kind of sketching the original graph over top just to give a visual. This goes from something that was positively, and then it hit that 0, and it turned around and it started coming back down. It was negative. So that means -1 is a maximum point. Okay, -1. I'm going to leave that y-coordinate for a second. Okay, when we change from a negative slope to a positive slope, so we're going negative slope, right? Negative slope to a positive slope, because we make that turnaround at 2, that gives us a minimum point. So we have a minimum at 2. The reason I left these blank is because now I need to kind of refocus and go back to the original function and put them in here. So I'm going to substitute -1 in here for x. And when I do that, if I substitute -1 in for x, I get 7. And now I'm going to substitute 2 in for x. And when I do that, I get -20. I've already calculated those. You could go back and check my work. But I already went through and did those substitutions, so I would know them. Okay? All right, so looking at this one here, we are going, this is an asymptote. So that means the graph actually doesn't touch anything here, right? And it doesn't touch anything here. So those would be asymptotes on us. Okay? And this says that it has a negatively sloped tangent. So we're going down. And we're still going down. So for this one, we have a negatively sloped tangent. And then it changes at 0 to a positively sloped tangent. So what that means is that we have a minimum point when x is 0. Okay? And here we're still going positive. Okay? So that's not going to be -1 and 1 are neither minimums or maximums, which makes complete sense if they're asymptotes. There wouldn't actually be any points there anyway. All right, so we have a minimum point at 0. If I substitute 0 into here, I have 0 minus 4, so -4, and 0 minus 1, so -1. -4 divided by -1 is 4. So we are starting with some critical points already. These are some critical points where things happen on our graphs. Those are important points to us. So these are going to be where we're changing direction. So our minimums and our maximums. When we get into optimization, these points are going to be the most significant to us. One of the things this can be used for is way back when we were doing quadratics, there was a lot of times you were asked to find the vertex of the parabola, and you had to go through completing the square. Or you had to find the x-intercepts and find the point between them, or do all of that kind of stuff. This is another form where you could find the vertex of a parabola, because you'd either be looking for its minimum or its maximum. And that would happen when the slope would equal 0. And you could tell whether it was a minimum or maximum by whether it went from positive to negative or negative to positive. Okay? So our last one here says that we went from positive to positive. So the way we would write that is we would say, oh, there's no sign change, which implies no relative extrema. Okay, so hopefully that helped out. And what we're going to do right now is we're going to move